Professor Avi Loeb is with us. Avi, how are you, sir?
Doing great. Thanks for having me.
It's great to have you on. So, can you just please explain, are we just seeing these things more than we ever have because we have the eyes now in space to see this?
Yeah, over the past decade, the astronomers constructed the new survey telescopes of the sky. Also, we have much better computers that allow us to digest large data sets. But the motivation for building those survey telescopes is a task that Congress gave to NASA and the National Science Foundation, NSF, to survey the sky for any objects that are near Earth that could collide with Earth, because that poses a risk. And they posed it as the challenge of finding all objects bigger than a football field that may collide with Earth, near Earth objects. And there were two major observatories constructed back a decade ago. There was Pan-STARRS in Hawaii, and recently, in June 2025, a new observatory in Chile was inaugurated called the Rubin Observatory, funded by the Department of Energy and the National Science Foundation. And those allow us to see objects that are the size of a football field and have a complete survey. And amazingly, in 2017, an object like that was flagged. And then the astronomers realized it's actually moving too fast to be bound by gravity to the sun. So it came from outside the solar system. It couldn't have been around. So that was the first. It was given the name Oumuamua, which means a scout in the Hawaiian language. And then
hold on just a second, because I remember this, and I think I talked to you around this time. Explain what you meant it was moving too fast.
The planets orbit the sun. For example, the Earth moves around the sun at a speed of about 30 kilometers per second, which is faster. It's 300 times faster than the fastest race car we have. I'm talking about 30 kilometers in 1 second. That's about 20 miles in 1 second. That's the speed by which the Earth orbits the sun. But imagine boosting the Earth, just giving it, attaching a rocket to it. Once it would reach a speed of about 42 kilometers per second, just bigger by the square root of 2, 1.4 times the current speed that it's moving, it will be able to escape the solar system. So it just needs a high enough speed to escape from the gravitational potential well of the sun. And we know what this speed is. And so if we see objects moving near the Earth at more than 42 kilometers per second, we know that they cannot be bound by gravity to the sun. They must have originated somewhere else. And so Oumuamua was one of those. And since then, we found two more with telescopes. I actually identified with my student a fourth one, which was found by the U.S. government satellites that are monitoring the Earth. That was a meteor that came from interstellar space. But at any event, the most recent one was found by a small telescope in Chile called the Atlas, again, to identify risk for Earth. And that one was given the name 3I Atlas.
So help me out on this, because, I mean, we didn't have these telescopes. This is obviously a relatively new thing that we're doing. How much damage does a football field size comet or space debris, what would that do? What was the size of whatever killed the dinosaurs, if that indeed was what happened? What is an Earth killer size?
Yeah, well, the size of a football field can, an object like that, if it collides with Earth, can cause regional damage, much more, like of order 1,000 times the Hiroshima atomic bomb energy output.
So kind of like what happened in Russia back in the turn of the last century?
Yeah, something. Okay. No, that one was actually much smaller than that was 1,000 times less massive. So,
oh my gosh!
These big ones are really rare, and that's why I will say, as we continue the discussion, I will mention this new one. It's estimated to be, of order the one that killed the dinosaurs, and these are extremely rare. And so the question is, why are we seeing an interstellar object that big, just within the last decade? But coming back to your question, the size of the asteroid that killed the dinosaurs was roughly Manhattan Island. Okay, so compare the size of a football field to Manhattan Island. It's a very different scale.
Yeah.
And so what the Congress wanted NASA to do is identify those that will cause just regional damage, not a catastrophe like happened with the dinosaurs, where there was a nuclear winter. The Earth was covered with dust, and So 75% of all species died at that. And we owe our existence because after the dinosaurs died, the more complex animals came along, and we are one of those species.
So you say they're only looking for the small ones, but I'm sure if a big one shows up, you'll ring the bell.
Sure. No, it's much easier. It's much easier to see the big ones.
Right.
Yes.
And do we have any technology that can move these things out, or is this just something that we're not? No, just another thing on the plate. Oh, by the way, this could happen, and it's coming our way, and there's really nothing we could do. Is this just a big worry, or is there things that we can actually do?
Yes, we can, because if you catch it early enough before it comes close to Earth, you just need to nudge it a little bit to the side, and then it will miss the Earth. And there are all kinds of proposals for how to do that. You can, the most aggressive one is to explode a nuclear weapon on it.
But wouldn't that break it up, and then we'd have all kinds of little meteors coming our way?
Yeah, exactly. That's why it's not a good idea. The Patriot missiles were doing just that, and they created when they were operated back a decade ago. They created much more damage than help, actually. But you can do it in a more intelligent way, maybe explode the weapon close to the object so that it doesn't disintegrate, it just ablates part of it, and then you get the rocket effect from the ablation pushing it. But there are other ways. Some people suggested painting it on one side so that it reflects more sunlight on one side, and then it's getting nudged a little bit. You can imagine shepherding it by gravity. The spacecraft is massive enough, and it shepherds it. It attracts. It basically gives it a gravitational nudge. There are all kinds of methods that were proposed. And by the way, NASA just a year ago they tried one of these methods with a mission called DART, where they collided with an asteroid just to see how much it gets kicked as a result and what happens to it. And it was quite surprising because, some of these asteroids are not very rigid. They are porous, and you get all kinds of dust thrown out of them in ways that were not anticipated. So at any event, the people are thinking about, rocks. Rocks are easy to deal with because in principle you can tell what their path would be. However, one thing that was never discussed is the kind of thing I'm trying to advocate we do is what if there is some alien technology out there, then if it was designed by intelligence, you won't be able to forecast exactly what it would do. It's just like finding a visitor to your backyard. The visitor may enter through your front door. You have to act immediately. And you need to engage with it in ways that are much more complicated than dealing with a rock.
Okay, so let me another thing. Here's something else you can worry about. So let me start there because there's some things that I've been reading. I don't know what's true. I don't know what's not true on this 3i Atlas, and I want to break that down, including the WOW signal, which I think you had something. You were there, weren't you, for that in 77 or whenever that was? Okay, so I don't know what's real, what's not real. I don't know who has credibility. We've heard so many things about, extraterrestrial technology. We had, all of the drones in the sky that everybody was thinking aliens were going to invade us for a while. And the world is on edge. I mean, we're very 1938, 39 War of the Worlds kind of territory in America. And I think the world, we're freaked out about everything. So tell me about 3i Atlas and why you say it may have alien technology. Right.
So let me give you the facts. I mean, the whole point about doing science is that we can collect evidence, data from instruments, and we don't need to rely on stories that people tell.
Right.
So what are the facts that make it really unusual? Well, first of all, it's the size. As I mentioned in the beginning, we expect many more small objects than big objects. And the previous two interstellar objects were roughly hundreds of meters in size. The first one, Oumuamua, was of all the football field, 100 meters. And this one, I wrote a paper 2 weeks ago that shows that it's bigger than 5 kilometers, comparable to the size of Manhattan Island. And that means it's a million times more massive if you take solid density relative to the first one, Oumuamua, a million times more. So how can it be the third object? We should have seen millions of Oumuamua-like objects before seeing a big one like that.
Yeah, but we wouldn't have. But we didn't have the But we didn't have the technology to see it, right? I mean, these things could have been passing us.
No. It's easier to see the big ones because they reflect much more sunlight. So, in fact, especially if they shed mass, Oumuamua did not shed any mass. There was no gas or dust around it. We just saw the bare object, and it was already puzzling because of that. It was pushed away from the sun by some mysterious force. It was most likely flat. Had an extreme shape,
and it accelerated, right? It didn't just whip around the sun; it accelerated, which does not naturally happen.
Yeah, well, it happens if there is a rocket effect. If there is if it's losing mass in one direction and getting a recoil in the opposite direction, but there wasn't any mass loss observed from Oumuamua. Nevertheless, what I'm saying is, an object that is a million times more massive is much easier to see. When we talk about it being within the distance of the Earth from the sun, and so we could have seen that easily. Many of those small ones before we see a big one. And then the second one was a comet very similar to the type of natural comets we see, and that one was 1,000 times less massive than this new one, 3I Atlas. So the size is anomalous. It's just surprising that we would see a giant one like that. There is not enough rocky material in interstellar space to supply such a giant one once per decade to the inner solar system. We would expect it once per 10,000 years or so. Anyway, that's the size anomaly. Then there is the fact that, the Hubble Space Telescope observed it and noticed, in the image, it displays a glow that is towards the sun, pointing towards the sun, instead of what you usually see for comets, where you see glow pointing away from the sun. And the reason you see that away from the sun is because dust and gas are being pushed by the sunlight and the solar wind away from the sun.
That's what gives it the look, a comet, a look of a tail.
Exactly. That's the definition of a comet. So then, all the comet experts said, oh, look, here is a comet, because we see this extension of a glow. But what they didn't realize, so they were, it's just like seeing an animal in your backyard. And everyone says, oh, it must be a street cat because it has a tail. But then you look at the photograph of this animal and you see that the tail is coming from its forehead. And you say, well, how is that a street cat? A common street cat does not have a tail coming from its head. So anyway, this one is the first one, that shows such a thing, and unlike regular comets. And then in addition, so these are two anomalies so far. In addition, the trajectory of this object is aligned to within 5 degrees with the ecliptic plane of the planets around the sun. And the chance of that is 1 in 500. So basically it comes in the plane where all the planets are moving around the sun. That could be by intelligent planning, because if you wanted to do a reconnaissance mission, coming close to planets, that's the way to do it. And the previous one came, both Oumuamua and the second one, Borisov, came at a very large angle. So this one comes straight in the plane, and you ask why? Why is it coming in the plane? And by the way, all of these anomalies, nobody that is calling himself or herself a comet expert, they just say it's a comet. But if you ask them, why is that? They would not have an explanation. Why does it come in the plane? Oh, it's by chance. Why is it so big? Oh, it's by chance. why is it, why does it have this glow towards the sun rather than away? Oh, it's something we don't fully understand. So they would say that, but they would not admit that it could be something else. Then there is the arrival time of this object. It arrived to the solar system at a special time because it's passing, very close to Mars, Venus, and Jupiter. And, these planets are moving around the sun, and you have to be at the right time, at the right place, in order to come within tens of millions of kilometers from each of them. And so that's another coincidence that, might indicate fine-tuning, that, there is some reason that it's coming so close. And then,
so hang on just a sec. Hang on. I just want to clear some stuff up, and then I got to take another break. All of these things could be chance, right? But you're saying now they're just all
the probability for each of them is very small,
right?
And then
so
you need to
multiply
need to multiply each likelihood
Correct.
by another, and you get something like 1 in a million chance.